Alright, MS-DOSX, let's get going for today. Today is probably going to be very short. It's just sort of a quick overview of view controllers, which you might have sort of seen before in some of the earlier labs. This is a slightly more formal explanation of what a view controller is and why they're useful and why they're used all over the place on iOS and Mac. And then you'll have a lab at the end of the day, which is actually going to give you some hands-on examples with delegation. And delayed that until today, so that way I could talk a little bit about view controllers before you start that. And then at the end of this, I'll talk about provisioning for your iPhones for actually doing testing on your devices. So we'll get to that. There's a few hoops you have to jump through, so I'll talk about how to do it. So the class we're going to talk about today is UI View Controller, which is the superclass of all view controllers. And generally, the UI view controllers and their subclasses that you customize are the primary way that you structure your user interfaces. The idea is that a UI view controller is responsible for one pane of your application's content. And Apple provides a lot of specialized view controllers that can contain other view controllers to allow you to build even more complicated user interfaces. So you've probably seen on iOS, for example, these apps that allow you to drill down into, for example, on the iPod, you drill down, so you choose an artist, you choose an album, and then from there you choose a song, so you kind of see these pages keep getting pushed on the screen. That's a specialized view controller that we'll talk about next week. But it manages a series of view controllers, each of which is responsible for what's on the screen at any given time. The conventional wisdom for how many view controllers you need is typically Apple and others have recommended that one view controller is responsible for one screenful of content. That's actually taken directly from the Stanford lectures, I think, that phrase. But the idea is that one view controller should be responsible for one screenful of stuff that's on your application, and no more. And generally that means there's one view that's managed by a view controller. So as we've talked earlier about the model view controller paradigm, and I hope it's obvious that view controllers are in the C part of that. They're controller objects. They mediate between the view they manage and the model that you've created, so that way you can keep track of your application's state. And so an example here, this is an example screenshots from the lab you're going to work on today. So we have this tab bar here, which we'll talk about in more detail later. But again, a tab bar is just a view controller that Apple's provided that manages other view controllers. So this left panel here, there's a view controller that controls everything that you see on that screen, minus the tab bar. And then there's a view controller that manages this really uninteresting view here on the right. And there's another one, presumably, for the rightmost tab. But the idea is that there's a view controller for every screen full of content. So it doesn't make sense for one view controller to manage all of these screens. Each one of these screens is managed by its own view controller. It talks to its view and talks to possibly a shared model. Does that make sense? Okay, so some interesting methods on UI view controller. The first one is the initializer. So the default initializer on UI view controller is init with nib name bundle. So it takes the name of the nib to initialize with. So as you've probably seen in some of the example labs, there's often a one-to-one correlation between a nib for a view and a view controller. Typically, the file's owner of that view is some instance of a view controller, and so this init with nib name takes in the name of a nib file that represents a view, and it will set this view controller to be the file's owner for that view, so that way they can now talk to each other. And so both of these can be nil. So if you the bundle, you've probably not seen much with bundles before, but the idea is that your application is wrapped up into bundles. So Xcode automatically makes the main bundle for you as it builds the application. Typically, you don't need to worry about bundles. You can always just pass a nil and just let it use the default bundle. But if you are building a complicated application with lots of bundles, then you'd have to specify which bundle the nib is actually coming from. If you would like to, rather than use a nib, but you would prefer to create your view for this controller programmatically, you would pass in nil instead of the nib in place of the nib name. So if you want to create your views programmatically, there is a method on UI View Controller called load view that if the view is not present in a nib and is not loaded using init with nib name with some nib file, that load view gets called in order for you to programmatically set up the view hierarchy. And there's really one expectation of load view, and that it is that you define the instance variable view for this view controller subclass. So UI view controller has a like I mentioned, it has an instance variable view of type UI view, and it's the kind of the root view that it manages. And so after load view is completed, it's expected that that property has been set. And so, like I said, this will actually get called automatically when the view controller needs to be put on screen and the view property hasn't been set yet. So if it's coming from a nib, this won't get called because the nib will, part of initializing the nib would be setting the view property to be non-nil. But if you want to create it programmatically, you do it this way. So you'll typically it's a one or the other operation. You either make your view from a nib or you override load view. You can't do both. If you override load view and have a nib, I'm not sure what you're going to get. I'm guessing it's the nib because I don't think load view will even be called. So, be warned. Yes, there we go. So if you have a nib, don't override this because it won't be called. And so, like I said, the view property of the view controller needs to be set after this method exits. If you want to create your own, if you need to customize the frame rectangle of your view, you can customize, initialize it using UI view alloc init with frame, give it a frame, and assign that to the view property. Or you can just let the superclass take care of it and just call superload view, which will set the view property automatically. And so it's not uncommon for the body of a load view method to be the first line superload view, and then below that all of your custom initialization. Once you know that a view has already been set, you can add subviews and do all that good stuff to set up your view hierarchy. Another really helpful method is view did load, which gets called after the views are in memory and are actually on screen, I believe. And this will get called regardless of whether or not you're loading from a nib or you're doing it programmatically. And so typically this is used for doing additional programmatic customization after the view has finally been put on screen. So if you before were thinking, okay, I'll have a nib and then put some additional stuff in load view, like I said, that won't work because no load view wouldn't get called in that case. So view did load is often the place to put that kind of logic that once you load, do extra stuff. Similarly, there's view did unload, which gets called when the view controller, just before the view controller gets released from memory. It's the counterpart to view did load. So typically, if you allocate any memory or alloc or copy or retain anything in the view did load or load view, it should be released in view did unload to keep your memory balanced. There's a one-to-one correspondence between these method calls, so you guarantee that you're not going to over-release or under-release if you make sure that you're balanced between these two methods. There's also some useful ones for the view appearing and disappearing from the screen, which is slightly different from being loaded. View will appear view will disappear gets called if another view gets put over it. So if you are in, say, iPod and you tap on an artist, the list of artists page gets viewed. View will disappear get called in it because there is another view in place of it. But then view will appear gets called after that view disappears again. So if you want to do some custom behavior as your view appears and disappears from the screen, you can override these methods to get that custom behavior. The really useful one is on iOS is should rotate to interface orientation, which is a rather long method name for. This is the method that gets called when the iPhone gets rotated, and it needs to know if the orientation that the phone is currently in is supported by the view controller. And so basically, it passes in an orientation that it's interested in, and if you want your view controller to be allowed to be viewed in that orientation, you return yes. If not, you return no. And then it won't. If you say no, it will not auto-rotate when you get to that orientation. If you say yes, then it will perform an auto-rotation when it gets that orientation. Does that make sense? There are, of course, a lot more. UI view controller is, like I mentioned, a very, very important class, and there's a lot of really useful things you can do with it. And I think Apple's documentation about the view programming guide does a really great explanation of how to handle multiple view controllers and multiple views and what goes in what, and kind of how to keep your application logic and flow sensible. So please check the documentation to see more about this stuff. One last thing that I wanted to mention is that it's pretty, like I mentioned, there's a pretty common correspondence that there's one view controller for every nib, and again, doing this with Interface Builder is really easy. You can create you create a view nib, and then you just set the class of the file's owner to be the class of your view controller, and then once you'll alloc and initialize one of those view controllers with nib name, give it the name of the nib file that this view lives in, and then that file's owner property will be set correctly. Any questions about view controllers? That's really all I add. Like I said, it's a short one. You've kind of seen bits and pieces of view controllers already. Glenn on Thursday will talk a bit more about view controllers on Mac and window controllers as well, because they're kind of similar. Okay, so any concepts, questions? No? Okay, so before I let you go, I did want to talk a little bit about device provisioning, which if you haven't done it before is mysterious and complicated the first time you do it.
The next few times too.
Yeah, and then it's kind of complicated. So the way it works is Berkeley has a university developer program with Apple, which, so as you've seen, anybody can get a developer account and anybody can write an app for the simulator. It won't let you deploy out to a device. That requires authentication with Apple, and you have to either be a paid developer, pay $99 a year, or the university program gives the ability to deploy and test on your devices and nothing else. So there's no distribution whatsoever. There's no ad hoc distribution. There's no App Store distribution, but you can test it on your devices. And so if you want to actually distribute it, then you have to pay. You actually still have to pay. But we have a program that allows you to at least test on your devices. And so I'll be sending out invitations to everybody in the class. So if you are hoping to be able to do that, then check your inboxes and accept that invitation, and then you'll be able to. And then I'll put directions on the website of the actual details of what you need to do it, because there's a lot of hoops to jump through. But the first thing you'll do is you'll create a certificate request. That's done using the application keychain access. It's again the portal does a pretty good job of explaining it, and I'll try to clarify anything that's not clear. But you'll basically request a certificate. I'll approve the certificate. Then you'll send me your device information, and then I'll create a provisioning profile. You'll install that provisioning profile on your device, and then, with any luck, Xcode will let you build out to that device. So that's the plan. Like I said, I'll send out invitations soon, and I'll have the directions up on the site pretty soon to kind of explain what you need to do to go through that. We also have 5 to 10 iPod Touches, second generation, I believe, on loan if anybody wants a device to test on and doesn't have one. Like I said, it's a limited supply, so if you have your own device already, don't ask for one. We won't give you one. But if you need one, then I'll take a list today of people who are interested in having a device, and I'll see how many I can actually give out. Cool? Any questions about this stuff? I'm sure you will once you actually start doing it. It's kind of complicated, but we'll try to do our best to help you. Okay? Okay, so the lab's up. Have fun with it.
Does there always have to be a
No, so there's another, UI view controllers do respond to init, and the implementation of init just calls init with div name bundled with nil for both parameters.
I vaguely remember being a convention that when you're doing load view, you're supposed to not do any computationally expensive or like slow things. Like you can instantiate a bunch of variables, but you're supposed to hold off on like positioning them and all that until we did load view.
I don't know. I typically do all of my frame computation inside of load view, and I've never had a problem with it.
Yeah, this was something Scott mentions, but he hasn't worked with it. He's kind of an efficiency.
I got that impression, actually.
Yes, okay. I didn't know.
Yeah, if that's a convention, I'm not aware of it.
I I don't actually know. I think I remember mentioning it.
But it's, I mean, unless you're doing something if you're doing something pretty reasonable, it's not going to be an issue. I think.
Yeah, maybe there's some implementation advantage to doing it.
I'm not sure.
Yeah, I'll have to ask him.
Okay, any other questions? Okay.